Okay, so what's our next step? We had said it was igniter, right? Tip big FB, thermostat, inducer, pressure switch, board, which are my safeties, and my igniter. So I removed the screw and I was able to pull out the igniter from here, the hot surface igniter, right? So you can see it. I have another one on my hand, but this one I'm just gonna leave here. But this is the one that turns cherry red. And so we're not gonna talk too much about the spark igniter. I'll do another video on that at a later future. But the hot surface igniter looks like this. When you buy a new one, you want to make sure you don't touch this part. Now, this has been touched by a lot of the guys that sometimes just have grabbed it, and this one which is used for demonstrations, just to test it. So this one's been touched a lot, but the idea is that when you buy a new one, you don't touch this part because the oils in your hand will disrupt the function of the hot surface igniter. So you want to be careful not touching this with your hand. Just kind of touch it from here. So this is the part that turns cherry red, right? Because in a fire, to produce fire, you need fuel, oxygen, and a spark. So in this case, we have some oxygen, right? It's pulling a draft. We got oxygen. We have the gas, which is my fuel, and we have the spark. So a hot surface igniter, this one's simple. This one receives 120 volts. So you know that it's receiving 120 volts, obviously, because it's turning cherry red. But how do you check it with no power present? So I'm going to go ahead and go to my meter, right? You can see my meter there. And we're going to put it on ohms. You have to put it on ohms. And you want to make sure you get a reading. You do not want to get open line. So simply put in here, you got the points where you connect your leads. So I'm gonna just connect the leads in there, right? So basically what it is, and I'll show you right now. First, let's get a reading. So look at the meter right there. I'll do a closer look up. I'm reading 14.8 ohms, 14.8. So that's good. That's good a reading. And actually, different hot surface igniters will have different resistance values that you're looking at. So you can simply just go to the one you're buying, look up the document, and it'll tell you what you're looking for. But you do not want to see open line. The idea is that it's going on one wire, right? It goes on one wire, and you can kind of see it right there. There's a little gap in between, but the idea is that there's a path from here to here. Remember what I said about 120 volts, black and neutral, or even 24 volts, hot and common? They can't touch each other because they'll start to spark, right? They can't touch each other. So in this case, in a way, they are touching each other, but they have this special piece here, and it basically kind of collects that current, that heat, and that's why it turns cherry red. So that's all it's doing with the hot surface igniter. You're like, wait, I thought hot and neutral can't touch each other. Well, we have a special part, special element. It collects the heat. It turns cherry red for a couple seconds just to get that spark, and it works. That's how it works. So of course, if you also want to check, because it could happen that this hot surface igniter is not working properly, so you have to turn off power, right? Obviously, turn off power, isolate it, and then ohm it out. And if it's good, then okay, it's not the hot surface igniter. You gotta make sure if the board is sending 120 volts, the board can go bad. It definitely can go bad. So right here with this hot surface igniter, you see this one here. So I have the hot surface igniter. So I'm gonna pull this out. Right, I pulled it out. Okay, and I'm gonna check now for voltage right there. Right, this is what sends 120 volts to my hot surface igniter. So you'll see that it does send 120 volts. So let's get that meter up right there. Let's put it on volts, right? We got to put it on volts. And then I have let me see if you're able to see the meter. There we go. And I have my plug right here. So I'm going to go ahead and connect it first, right? And then let's go ahead. Okay, so we're good. So let's go ahead and call for heating. All right. Look at my meter, right? It's gonna send 120 volts. Obviously, I disconnected that hot surface igniter, but I just want you to see that this is how you would check. if the board is actually sending 120 volts, right? If it's doing all its steps, but it doesn't send 120 volts, and there's a problem. You see, I'm getting 120 volts. I heard that little relay kind of click, but yeah, it sends 120 volts out. So these are the two tests that you do. Make sure that the board is sending 120 volts, and then with no power present, you would check the hot surface igniter and check that you're getting a value, a resistance value. You do not want to get an open line on these. All right, so the next step is G, gas valve. So for this one, I am going to move on to this furnace. We'll go back to the original furnace that we were working on, but this one here, it's just easier for you guys to see what I'm going to be doing. So first step is make sure you have the ball valve. It's open, meaning you're going to allow gas to go through, right? So that's the first step. Of course, also make sure that that is on the on position. So make sure that's also on. So we did that, and you know what? I gotta connect that flame rollout back. If not, the unit will not work. And then my high limit that we disconnected earlier. So let's go ahead and do all that. So all right. So now, when it comes to the gas valve, yes, you do need a manometer. You got to be able to read inches of water column. So typically you have about 8 to 11 inches of water column coming from the city, and then outputting it should be about 3.5. Different gas valves, different manufacturers will probably say 3.4, 3.3, or 3 point something around that, around that ballpark number. But 3.5 is usually a good number. And if it's a second stage heating, it normally will output 4.5 or a little bit higher to produce more BTUs. But I'm just going to show you how to check it. So here, let's get a little bit closer here. You have this part here. There's a little, like a little nut there. When you buy the little kit to read it, it comes with an Allen key, a special Allen key. And I think this is a 332 size. So all you're doing is you're just going to crack it open very little. You're not going to take that out completely. And so I already have my manometer. And you know what? I'm going to actually, let's see if I can put it down here just so I can show you guys. Okay. Maybe that's pretty good there. Okay. So there we go. So yes, when you need the Allen key and you need these fittings here, this one literally goes over all that. It literally goes over that so that it can push the pressure out and we can read it. So I'll show you right now. You'll see it right now. So first I have to connect my poly tubing right here, right? So let's go ahead and connect it to my tool, to my manometer. Okay. Let's go ahead and turn it on. Right now it's at 0. So this is what you're doing. So right now, you see I'm already getting a reading, but I haven't connected anything. So I'm gonna 0 that out. And there goes the poly tubing. I didn't put it correctly. Let me go ahead and put that back. Make sure it's in there. Okay. All right. I don't think that's going anywhere. So, all right. So let's go ahead and 0 that out. Okay, so this is what you're doing. Get the Allen key. So have this ready too, though, right? Have your poly tubing, right? Having ready, and this comes and when you buy it, it comes in one piece. It's like a gas valve testing kit. So it comes already all set up. This is literally going over that completely. And what I mean by that is, look at that. It just went over the whole thing. But I'm not reading anything because I haven't cracked the little Allen nut inside. I haven't opened it. So what I'm going to do right now, so let's go ahead and 0 that out again. Okay, 0 it out. Open this. Okay, get my Allen key and crack it. Crack it open. Lefty loosey. See, you can hear that gas valve coming out right now too. I'm going to push that in. Push that in. And I am reading 6.59 inches of water column. So I did say 8 to 11. Even if you read 7 to 12 or 6.5, they'll still work. but I'm reading 6.60 or close to 7 inches of water column. So that tells me that I am getting incoming gas pressure to the unit, to the system. Okay. So that's the first step. We want to make sure we're getting incoming gas pressure. So you see, I literally put it over the whole part there. And because I cracked it open, that gas is seeping through around that little Allen nut. It's seeping through enough to create that gas pressure. You don't need to take that Allen nut out completely. You just crack it open. Okay, so now we're gonna do the outlet, right? So I'm gonna go ahead and open this, and you see I'm getting some gas coming out. So you gotta make sure you close this, righty tighty. So make sure you close that. Okay, that's good. So the other one, the outlet is right there. You see, it's right there, and it even says out, P, right next to it. So same thing. I'm gonna go ahead and crack that open. So obviously right now, we're not getting anything out because we're not sending voltage to the gas valve, but I'm just gonna get it ready for you guys so you guys can see. Okay, so now I'm gonna zero that out. All right, so let's see how much gas pressure we have coming out. I'm gonna call for heating. All right, so it's zeroed out. Give it a second. Let's see how much pressure we have coming out. Let's see. We are at 3.5. You see right there? 3.5. But let's say just for the heck of it, you were at 4, or you wanted to adjust it. You have this little brass cap right here that you take out. So you need a flathead. So lefty loosey. There, I took it out. And inside there you have a way to regulate the gas valve. But you want to be careful because that's made out of plastic. So you can easily just destroy that. But you're going to use a flathead. And look at my gas pressure there. To increase it, so I'm going to go ahead and put my flathead in there. You see, as I go to the right, look at that. It went from 3.5 to 3.8. If I go to the left, I have less gas pressure coming out. You see, I'm going to the left. I'm spinning to the left. You see, now I'm at 2.8. But we want 3.5. So let's go ahead and increase it. That's good. We'll leave it there for now, just for you guys to see. 3.5. So that's how you adjust the gas pressure. But yes, you have to be able to have a way to test the gas pressure. You need the little kit, the tubing. And another thing too, last thing, you want to make sure you have voltage going to the gas valve too. So remember, it can fail mechanically or electrically. So all you're doing is you're making sure you're getting 24 volts. So you see right there on the 2 leads that are going there, all I'm going to do is put my leads in the back, and I have to have 24 volts. So you see right there, I'm getting 24 volts. And obviously I know I am because I'm getting some gas pressure and I have some flames. So that's how you will check this gas valve. Now I'm going to show you how to check another type of gas valve that you'll see out in the field. Okay, so the other gas valve, you needed an Allen key about this small to open the little nut. But you see this one here is a little bit different. It's a little bit bigger. And you need a different fitting or adapter to be able to read the gas pressure. But I'll show you guys right now. So in this one here, you do not need these two right here. You don't need the small Allen key and then this piece that we used in the other gas valve. You're going to need this bigger Allen key, right? So if you have an Allen key set, you just, I can't recall right now which one it is, but one of the ones that you have on your Allen key set will fit there. And then you're going to need this fitting here, right there. This one here. And they sell these everywhere at your local HVAC supply store. So, but I'm just gonna show you how to read this one. So let me see if we can get a better picture. Right. So this bottom part here that is threaded, the bottom part is what is gonna screw in there. But you have to take that out. So what I do, I make sure the gas valve is off, and then you're just gonna take it out. So let me see if you can see a better view there. You're literally just taking that nut out. You're just taking it out. So look at that one right there. I'm gonna take it out. So lefty loosey. Okay. So take that out. All right, it's out. So of course, if I were to open the gas valve right now, look at the gas coming out. You see that? Gas is seeping out. So you gotta put this fitting here now. So that's why I always make sure the gas valve is off first. So righty tighty. Make sure that's pretty tight. Okay. And then now my manometer, I get my tubing, and I don't need any fittings. I just need just the tubing that goes straight to it, just like that. Okay. And so let's go ahead and zero that out. And let's see how much gas pressure we have coming in here. So I'm gonna check the top right there, and let's open it. You see this one I have 8.67 gas pressure coming in here. But we're not gonna turn on this system. I just wanted to show you how you would do it with this gas valve. You need to buy the gas valve adapter kit. I can't think from the top of my head the actual gas valves, but these gas valves, I believe the Gemini brand, Gemini gas valve kit. But honestly, if you just go online and put gas valve kit, gas valve pressure kit, you'll see some options. But essentially, you're doing the same thing we did with the other gas valve. We're just gonna check if we have pressure coming in here, and then the other one, the outlet one, is right there. Let's see if you can see it. Let's see if I can zoom in. You see, it's right there, right there. So yes, to be able to read this properly, you do need the manometer, you need the tubing, you need the little adapter to fit in, but that's about it. That's all you need to be able to read gas pressure from this gas valve. And then once you're done, I'm gonna go ahead and close it. Right, I'm gonna go ahead and close this. Now gas pressure is closed. You see my inches of water column is dropping because I don't have any gas pressure coming in because I closed the gas valve. And simply you're just gonna take it out, lefty loosey, and then you gotta make sure, you have to make sure you put that back, the little nut. So you don't want to cross thread it. So like I said, you're just gonna put it back where it was, and get your Allen key. And then once you feel like when it's tight, you're good. Righty tighty. Okay, and that's good. And then you can do a simple test. You can open the gas valve, maybe use some soap and bubbles to see it's not leaking out. But normally, once you put it back in, you'll be fine. But this is how you would check this gas valve. All right, guys. Thank you for staying this long with me with this furnace video. I know this is a long video, but we're almost done. We're in the second to the last step. So now is tip big FB. So now we're in the FB. F is flame sensor, flame rectification. So in there, this is where you have the flame sensor right there. And it kind of makes sense because your igniter is right here on the first one. Your flame sensor is all the way at the end. So when this ignites, boom, flame, 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 flame. And then they put the flame sensor at the end, at the last flame. Because if they were to put this one on the fourth one, well, what if something were to happen right here on this one? It wouldn't be able to detect it. It would be obsolete. So that's why they put it at the end, because you want to make sure all the flames are working fine. And they put this flame sensor at the end. So you always see the igniter on one end, the flame sensor at the other end. But this is a closer lookup of the flame sensor. You'll see different ones. for different furnaces. This one here, you know, they're the same. You have a wire connected to it. You got a little screw you got to take or put, and then you just have the piece of rod, right? That flame sensor. So basically, this part here, right? This top part, that's what gets dirty. This is what's getting that flame. That flame is hitting that full on all the time when heating is on. So a lot of the times these get dirty. You got to use steel wool to clean them. You can even use a dollar bill. You do not want to use sandpaper because sandpaper, sand and heat kind of basically create glass. So if you use a sandpaper, it'll create a sand like a glass coating, and you won't get a proper reading. Which we're gonna show you right now how to check a flame sensor. But you want to make sure you use a steel wool, a dollar bill, something that maybe the manufacturer specifically recommends. But I've always been successful with using steel wool or a dollar bill if you have that. So that one, let's go ahead and check that. So the first thing is to make sure you have voltage coming in. So let's see if I can put this here so you guys can see the voltage. So, all right. So there we go. You guys should be able to see that. So that part here, you want to be able to grab the metal part, right? You see right there. I'm going to put my lead there and to ground. You can put it to neutral, but, and this is what I mean. Once I call for heating, put it on voltage. Put it on voltage. You want to make sure it should be getting between 80 and 100 volts. 80 and 100 volts. So I'm going to put it to metal. You see, I'm getting 97 volts, 80 to 100 volts. So you can grab, touch the flame sensor, and then anywhere in ground, 80 to 100 volts. So that's good. It's receiving, there's voltage present. So that's one thing. You want to make sure that the board is sending voltage to the flame sensor, right? So a good indication to know if you have a bad flame sensor is if that flame sensor is dirty. If that flame sensor is dirty, you will get flames for a couple seconds, and then after a couple seconds, the flames will turn off. That will prompt you to look at the flame sensor to see if it's dirty. So, with steel wool, right? I don't have steel wool right now, but you would simply take out the flame sensor, get the steel wool. Now this is just a rag; it's not steel wool, but just to give you an example, you just clean it, okay? But another way to know if your flame sensor is working properly or not is to check microamps. And the way you check microamps is you have to have this symbol, and I'm going to show you guys how to check it. UADC, microamps. So this is what I do when I check microamps. First, you put it on that setting, and I actually get 2 alligator clips because they will make your life easy. So right there, I have, you see, like that male connector. I put one here, so I'm gonna put it right there. And of course, there's no power pressing, right? I make sure there's no power. So okay, I put that one there, and then I got my 2 leads right here. So the alligator clip right now that I put on the flame sensor, and it doesn't matter which one's which. You might get a negative number, but all I care about is the number. So let's go ahead and put it right here on 1. And then this other one, so just go back with this, okay? So this lead alligator clip from here to where the flame sensor is at. The other one goes to the wire that I pulled out to the other lead. The black one here. All right. It's done. That's all I did. You see? Wire to the lead, and then flame sensor to the lead. And I have it on microamps too. So let's see if you guys can see this. So you see it's at 0 right now. I'm going to go ahead and turn it on, okay? And we're going to call for heating. Let's see. Because I removed the flame sensor, the blower motor turned on because it's like, hey, what's going on? I'm not sensing any flames. But let me see if I can reset it just by disconnecting power and connecting it back. All right, I think we're good. All right, there we go. So I have my leads here, right? But I want you to look at that right there. Look at my microamps. And I have it, you have to have it on microamps, right? Manufacturers will say 4 to 6. Some will say 3 to 6. A good rule of thumb would be 3 to 6 microamps. So keep an eye on that right here. Just keep an eye on that. And look, we're going to get microamps. Once we get flames. Right there. We got 5.5. We're getting microamps. And to be able to check this properly, you have to have the leads and the alligators connected, because right now that direct current is literally going through your meter. So if you disconnect right now one of those wires, it's gonna turn off because it's part of the circuit. But you see, I am reading 5. So if you go to a job and it says like 1 or 2, you might want to start thinking about cleaning that flame sensor. If you clean it and it still doesn't work, you might start thinking about replacing the flame sensor. But look at what I'm going to do right now. If I disconnect one wire, you see, so I just want to show you, we're getting a good flame sensor reading. If you disconnect one wire, I disconnected it, it's going to turn off because now it's no longer part of the circuit. So I just disconnected power, but I just wanted to show you guys when checking the flame sensor, that is what you're doing. You're making sure that the flame sensor is clean. You're getting the right microamp reading. Yes, your meter has to be on microamps, but you can use 2 alligator clips to help you in checking the flame sensor. And then one last thing about the flame sensor is that it's important that your furnace is grounded. So the idea is that you have voltage here present, and the flames complete the circuit. A contactor coil, a relay coil, you got your common and your hot. You need your common here, and then the hot comes. You need both to complete the circuit. Same thing. You have voltage here, 80 to 100. When the flames turn on and it hits the flame sensor, it completes the circuit. And the idea is that direct current will then flow through the carbon and the flame. And if this is grounded, it will complete the circuit. So that is why it's important that this is grounded, because that is why down here, you see, on that plug that we were talking about earlier, we have a ground, and then we have the flame sensor, right? This is the one that sends 80 to 100 volts, and we got our ground here. So that helps us to complete the circuit, but it's important that this part here is grounded. So any furnaces that you're working on, you got to make sure it's grounded. And what I mean by that is, you see this part here? That's grounded. So that's good. And then the ground coming from the pigtail, from actual power from the outlet, it's also grounded. So yeah, you have to make sure, because for it to complete the circuit, the current's going to travel through the carbon in the flames. And then if it's grounded, boom, it completes the circuit. If you don't have this grounded, you're going to have some weird intermittent issues. You're going to see that sometimes it works, sometimes it doesn't. Just make sure you have a good ground. And you can also have the ground wire present, but it won't be a good ground. Just making sure it's a very good ground, connected well. Even here, make sure it's a good contact, it's not rusted. And this is another thing you wanna check when dealing with the flame sensor. Okay, we're finally in the last step here, which is B, and the FB, which is your blower motor. So you're gonna see that it's gonna do all the steps, but it's not gonna turn on the blower motor right away. It's actually waiting for that heat exchanger, that chamber, that area to get hot. Because if it turns on right away, you're gonna supply cold air to the customer. So right here, you see right there, it says cool, and it has heat. So it has a PSC motor. So it's using the red wire, which is a lower speed than the black one, to send 120 volts. But I'm going to confirm, look, it's not sending 120 volts. I'm going to check that one in neutral. You see, you look at my meter. It's not sending 120 volts yet. It's still not on. We're going to wait a couple seconds. And you're going to see now that the blower motor is going to turn on right now. So let's give it a second. Now, this inducer draft motor has seen better days. Don't get me wrong. Um, it needs it needs to be replaced, but it's still working. You know, you could probably hear that on the background noise. So at least I can. It does not sound pretty. But let's see. I'm putting the wire in, and I'm checking the neutral. It hasn't sent out 120 volts yet, right? So it's gonna make sure that area and the heat exchanger is warming. You see now it turns on the blower motor. So if you go to a job and you're like, hey, my blower motor is not turning on, like you checked your capacitor, well, check if your board is actually sending 120 volts. And you check it once again by doing what I just showed you. But right here, it won't send 120 volts on this one. It's only going to send 120 volts on the cooling when you have a call for cooling. But when you have a call for heating on the W, it sends 120 volts through this one here. So now I have some airflow, and now you can supply hot air to the customer. But yes, you're checking if the motor is working well, the capacitor is good, you're ohming out the motor, and you're checking that the board is actually sending 120 volts to the motor to turn it on. Do you remember the acronym? TIP Big FB. Thermostat, inducer draft motor, pressure switch, your board ensuring all the safeties are closed, ignition, which is your hot surface igniter, your gas valve, flame sensor, flame rectification, and your blower motor. 8 steps. And the way that I like to approach the acronym, the TIP Big FB, let's say in the I, which is your igniter, let's say it doesn't turn cherry red. Are you going to check if for flame rectification, are you going to check your blower motor? No, you're going to check if your board is sending out 120 volts. You're going to check backwards. Let's say your pressure switch, the inducer draft motor turns on. Your pressure switch is still open. Are you going to check if your gas valve is receiving 24 volts? No, you're going to focus on the previous step to see if the inducer draft motor is pulling enough suction pressure. So wherever you're at, don't work forward, work backwards to see what's going on before you start working forward on the steps. And that's at least how I like to approach the acronym. It has helped me a lot when troubleshooting furnaces. Now, of course, this furnace here, I disconnected the flue, the vent, just to show you what a blockage would do. But a lot of the times you're up in an attic, horizontal, you don't have a lot of space, but just following these steps can help you with that. Now, going back to this, just doing a quick recap. The thermostat, the R, your power, sends 24 volts to W, right? So you want to make sure you're getting 24 volts between your common and your W. That's going to ensure that your W actually has 24 volts, that there's a call for heating. Your inducer draft motor receives 120 volts, it turns on. Your pressure switch closes because it's sensing this draft that the inducer draft motor is producing, is sensing this negative pressure. And then your board, your safeties must all be closed. It should not be open. Now you were able to see when comparing both furnaces, on this furnace, all the safeties are in series. The rollout, your high limit, if any of them open, it stops sending power to your thermostat. But on the other furnace, even when disconnecting the high limit, your thermostat still had power. It still shut down the furnace from operating, but only the rollout when pulling out the wire did it stop sending 24 volts. So you want to ensure that on the furnace you're working on, that you understand what's going on with the safeties. But at the end of the day, you just want to make sure that all safeties are closed. You should read continuity. And then your hot surface igniter receives 120 volts, turns cherry red. Your gas valve receives 24 volts. You were able to see how we were able to check the inlet pressure and the outlet pressure. You're looking in between 8 to 11, more or less, from the inlet pressure coming from the city. And then once it receives 24 volts, about 3.5 coming out, your flame sensor is going to detect that flame. So this is the flame rectification, and you're looking for 3 to 6 microamps, more or less. And your meter does have to have that symbol, the UADC, to be able to read that. And then the chamber, the heat exchanger area gets a little bit warm, gets a little bit hot, and after a couple of seconds, it sends power to the blower motor, and then it turns on. So yes, there's a lot of steps to a blower motor, to a furnace working, 8 steps. But whether you're working on an 80%er, 90% or 96%er, you can take these principles to help you out in your next service call. I hope this video helps, and I will catch you on the next one.